Okay, so let's talk about part 2. This part of the case study is going to look at the message passing portion of the backpressure aware app server. And if you're wondering where's the backpressure, there's really not much to be done on the server side, which is pretty cool. It's mostly on the client. So we're going to go ahead and take a look at the EX2 RSocket live lessons project and walk through the message passing oriented code. So here we are again back in the IntelliJ project file. Let's go ahead and take a look at the message controller. And the quote message controller has an auto-wired message service. And then it's got a bunch of endpoint methods, which are message mapping annotated. And they do various things like they let the client subscribe. They let the client cancel their subscription. And you can cancel either in a confirmed way or an unconfirmed way. That's really just there to test out different types of interaction models that are provided by RSocket. And then there's also a method called getAllQuotes. And getAllQuotes takes a subscription request and then returns the quotes. And of course, it's backpressure aware under the hood. Let's take a look at the implementation of this stuff. This is actually pretty cool. So you can see here we've got a pair of quote lists, one for the zippy quotes, one for the handy quotes. And you can see that they use that qualifier up here. And if we go over here and take a look at server beans, you'll see that we have two different beans. We have one that handles handy quotes, and we have one that handles zippy quotes. And they factor out a lot of code in common, and that code is in this private method called getQuotes, which essentially takes the file that we gave it, the list of quotes, and then it opens the file, and then it splits the file according to the little @ sign, which separates each of the lines, and it turns those things into the appropriate quotes objects, and we get those back as a list of quotes objects. Nothing too profound there. The only thing that's interesting is the use of the qualifier to specify which one we're trying to create. We also have a set of subscriptions. As I mentioned before, I've not been able to convince myself that there's concurrency going on here because this is an asynchronous reactive server. So I used a set, which does not have support for synchronization. If I can convince myself there's a synchronization needed, I would change this to a different kind of set. So let's take a look at subscribe. So subscribe is sent a subscription request by the client as a mono. And what it does is it takes the subscription request, and in the do-on-next action operator, it sets the status to confirmed, and it adds it to the set of subscriptions. Now, I probably should have done a little bit of error checking to say if it was already in there. I don't have to try to add it, but that's OK. And you'll notice that we print out what type it was. Is it for zippy or handy? What the status is, which should be confirmed. And also the request ID, which is this UUID that identifies the client uniquely, or the subscription request uniquely. There's also ways to cancel subscription requests. You can see that we cancel it in two ways, confirmed and unconfirmed. Unconfirmed just means it's a fire and forget message, doesn't send a response back to the client. Confirmed means it goes back to the client and says it succeeded. All we do is we call a little helper method that removes the thing from the set, which we'll look at in a second. And because this call is never going to be handled by the clients, it's one way, we have to run the subscribe operation in order to do this asynchronously. Here's the one that does it in a confirmed way, and you can see it takes in the mono, cancels it, and returns the mono after it's been updated. Here's the cancel subscription method that both of those other methods call. And you can see it checks to see if the subscription request is contained in the set. If it is, it removes it, changes its status to canceled, and then prints out a diagnostic. If it's not in the set and someone's trying to cancel something that's not there, then we're going to go ahead and say that the status is error, and we're going to go ahead and return that to the client. The client will do something when it gets back an error status. Then the final method here, which is really the fun one, is called getAllQuotes. This is really interesting. So what getAllQuotes does is it takes the subscription request from the client, and it checks to see whether it's valid by looking up in the map. If it is valid, then it goes ahead and takes either the zippy quotes or the handy quotes, depending on what the type is, and it streams it back as an iterable. And you can see that basically what it does is if it's not in the set, then it goes ahead and just returns an empty flux. So that's basically what that does. So that's essentially the message handling part. Let me show you real quick what messages actually are that are flying back and forth. Here's a quote message. A quote contains the quote ID and the string. So it's got a number, which is just the number it is in the database or in the list. And it's got the quote, so that's very simple. Here's what a subscription is. A subscription has 3 fields. It has a UUID, which is the subscription, unique subscription identifier. It has the subscription status, saying things like, is the subscription going to be pending, confirmed, canceled, or in error? And then the last thing is the subscription type. And there's 3 types. There's no subscription, which is the default, zippy, and handy. And as I said before, I probably should modify this so you can subscribe to more than one quote service at a time, but what the heck, we're making it simple. So that's what a subscription is. Those are the plain old Java objects that are sent back and forth between the client and the server. And I think that's pretty much everything on the server side now.